used Unity? Okay, sweet. Is there anyone who's never used it? Okay. Is there anyone who doesn't even know what it is? Really? Well, that's cool. We're going through a quick introduction to what Unity is, and some of the stuff I will be showing is kind of things which Unity developers will kind of need to know, and they'll understand a lot of the basics. But for those of you guys who don't know much, I'll try and go over it in such a way that's in context, and you can kind of understand what I'm trying to say here. But if you have a background in game development at all, that'll help. But if not, then, I mean, Unity is one of the fastest growing engines purely because it's so accessible. So you guys who don't know too much about Unity, don't worry, I won't scare you too much. So before we start, I'll just talk about myself for a little bit, because that's what I like doing best. Just so you kind of get to know me a little bit, so we can start being friends in some way, and then later on when you see me around, you can say, hey Russ, how's it going? And I'll go, yeah, don't talk to me. I just want to go watch Minecraft being played in there. And also, if you do fall asleep or something like that, at least you might dream about me as you're sleeping, which will be a bit weird, but you know, might be fun, depends what you're dreaming about. So I'd like to go over a few things which I've done in the past. Before I joined Unity, I was a game designer and a game developer at a few studios in London, and also doing some freelance work for people like Nissan and just picking up some Unity work. I also did teaching at London South Bank University, teaching game design and game development using Unity, which was cool. And I also organized the London Unity user group, which is, well, it's a user group which we put on every month for game developers in London to talk about Unity, talk about projects they're working on, or just to talk about, you know, just little kind of editor scripts and little things like that. So we have about 60 to 70 people every month who attend, and we have about 400 registered members just for London at the moment. And this whole kind of process of user groups is being replicated kind of throughout the world. So there's ones in Boston, and there's ones pretty much everywhere. So a few TV shows that I like. I do this because I always judge how different it is for each event that I do. So some people go, yeah, Mad Men, it's brilliant. Yeah, Don Draper is amazing. And then there's other events that I do are a bit more geeky, and they kind of respond a bit more to Game of Thrones. So I'm guessing Game of Thrones will be a little bit more appreciated here. I've seen a few Game of Thrones t-shirts going around, so that was pretty cool. 6 Feet Under was another one. Sex and the City, obviously. I don't even know why I put that on there, because every guy's going to have that on it. And then I just put this on because I love it. I think that's great. You've probably already seen that, don't mind. So anyway. So about Unity then, for the people who don't know, like, is it a game engine? Well, yeah, it is. You can make games in Unity. That's great. But I like to think of it, and other people like to think of it more of as a development engine. It's something that you can make games in, and you can make other things in it as well, and it's being used extensively in other areas outside of game development. So architectural visualizations, simulations, military stuff, training for like the medical industry, loads of different things are using Unity in serious games as well. So we don't like to pigeonhole ourselves as a game engine. It's so accessible and it's so open that anyone who has the vaguest application to make can use Unity to do that in. So it's cross-platform as well, which is what we're pretty much talking about today. So out of the box, when you download Unity for free from the website, you can deploy to PC or Mac. So you can put your games on those platforms. You can get people to play them. For those of you who aren't aware, Unity is free for the basic license. You can download it, you can make a game, you can sell a game, and you can make money off it. If you start making too much money, then you'll have to buy a license, but that's $1,500. I'm not sure what it is in euros, but it's very small, and there's no revenue shares either. So the barriers to entry are very low. Also out of the box for the free version, you also get a web browser deployment as well. So you can push that to most web browsers. All the common ones here, you get the Unity Web Player plugin. So you can send your games to friends and they can play it online. You can put them on things like Congregate and the main kind of video game portals. Or even just for the testing points in your game, when you're developing something and you want someone to play it, well, you can make a web player version of it, send it to them, and they can test it. If they find any bugs, at least you know about them. You don't have to wait until it's finished. iOS and Android, so that's what we're going to be talking about today. A lot of my experience is in iOS, so some of the examples I'll be showing are iOS specific, but the actual main important things which I'm hoping you'll take away will be kind of not iOS specific, and they will be platform agnostic for mobiles. Adobe Flash Player, currently in a preview, but will come in Unity 4 as a full-scale plugin product similar to the iOS and Android with basic and pro licenses starting out at $500, and then the pro one is $1,500. So you can deploy to Flash as well, which currently has 1 billion installs, and it's still the way to deploy content onto the web. We will be moving on to a little bit of Unity 4 at the end of the talk as well. And also current-gen consoles as well, so you can do console development. So pretty much everything that you play games on or you use in your day-to-day lives, you can play a Unity game on there. You can develop a Unity game for that. So that's quite exciting. Making that accessible to developers is a really important thing because you don't have to have a dev kit unless you're doing console stuff. But you can have your own iPhone and you can put things on it, your own Android device, and you don't need to have anything special. Asset Store is something that we offer for developers and also, well, developers to buy content on and also developers to sell content on. So people who've made Unity games and have had to build their own editor scripts or plugins that they've used to make their games, well, it's not just for their games. They can use it in any game, and they can use it in anyone's game. So they can put it onto the Asset Store and they can sell it or give it away. So other developers can download those, whether they be scripts or plugins or just kind of meshes or materials or textures, you can get those from the Asset Store. So for a rapid prototyping that you want to do and you want to get a few basic kind of primitives and standard primitives just to populate your level, well, there's free standard primitive packs on the Asset Store and you can download them and use them. You don't have to make them yourself. And the community as well. So I mentioned the user groups, which are insanely popular throughout the world, and there's also the forums, Unity Answers, the Unity wiki pages. There's a huge amount of content out there which you can get hold of. So if you're looking to get into game development using Unity, there's so much there you can just get hold of. I learned how to use Unity from pretty much stealing what people had put online. Like, they said I could use it, but it was a case of just Googling Unity, make something jump, and you'll get a forum post and it's got controls, and you can just copy and paste that and put it in your game and it works. So you need to still learn how that works itself to move on and improve, but just that immediacy of going from nothing and not knowing anything to the end of the day having a character moving around, that's a pretty cool thing to have. And Union as well, which is a service which Unity offers. So for people who have made games in Unity and have released them and they're on, say, the iOS store, for example, and they want to look at targeting other devices, say the BlackBerry Playbook, which is a similar device. It's a smart kind of device, a smartphone-esque, a tablet-esque device. You think it will work, but we don't offer a BlackBerry Playbook license. Union handle porting to non-specific devices, so iOS and Android you can do yourself, but BlackBerry Playbook, Roku set-top boxes, LG smart TVs, and loads of other devices as well, Sony Xperia Play mobile phones, there's a service called Union. So they'll take your game, they'll say, yeah, this will work on those devices, and there's a good chance it will sell. They'll do all the porting, they'll cover all the porting costs, so you don't have to pay anything, and then they'll release it using the relationships that we have with people like BlackBerry and LG, and they'll start selling it. Once it's sold enough to cover the costs that we've accrued, there's an 80-20 split. So that's where you get 80% of the revenue share and Union get 20%. So there's no risks to the developer. So if you are looking at building games and you want to put them on kind of smart TVs, then this is the service to do that. So let's just start with what we're actually going to be talking about. And yeah, it's pretty much what you need to know. And this is a kind of a story of how I made loads of mistakes trying to build an iPhone game and port an iPhone game from a desktop and web player build to an iOS device, not really knowing what my limitations were, what I should be doing, what I shouldn't be doing, the horrendous things I'd done wrong in the original development, and then trying to squeeze that into an iPhone. So that's what we'll be talking about, basically. Because the best way to learn something is to make mistakes, and I made pretty much every mistake in the book, so I'll be going through that today. A few mobile games, just to go over very quickly, just so you know kind of what sort of mobile games are made with Unity. Shadowgun and Dead Trigger from Madfinger, which are the standout iOS and Android games, really, in terms of visuals. Ski Safari, which is my favorite at the moment. Zombieville USA. Chop Chop Ninja 2. CSR Racing, which you might have seen in the Apple WWDC. Snuggle Truck, which is on pretty much all platforms now. And the official Olympics game, because the Olympics are on. That's made in Unity. And also Triple Town as well. People are aware of Triple Town. So 3D games, 2D games, serious games, anything that you want to make can be made in Unity. So this is an imaginary conversation that I've had with people. And it is pretty much so, what are the differences between making a game in Unity that you put on desktop or Mac and PC, and then making a game for iOS? And there aren't really that many differences, You just need to know about the little things. So that my presentation could pretty much be, yeah, there's not much. All right, we're done now. But yeah, there are little things you need to know about. And I sent a little tweet out just to some people to say what the best bit of advice is you could give to developers who are looking to put things onto iOS. My favorite one with Mike Bithell was the touch screen, which is quite important. You know, it's a different input device that you'd normally be using on desktop, PC, and web. But there's lots of little ones. Natasha says watch memory allocation. That's the huge one. That's what we'll be going over today. Scalability, what Emil said, designed to run scripts and graphics at multiple levels of detail, also makes a later PC port much easier if you're approaching it from that way. A lot of the mistakes I made was approaching it from the other way and trying to squeeze something down, but it's quite easy to start small and then scale it up, especially with level of detail systems and max LOD levels. You can create kind of level of detail for your meshes, but only use the very small detail ones, and then later on use the higher level of detail for different platforms. And things like texture resolutions and texture compression rates for different platforms, we'll be looking at those. So the first one, knowing your limits. This is where my advice starts. Draw calls, memory usage, and target frame times. So for anyone who's aware of what a draw call is, it's what Unity calls basically a message to the renderer to say, hey, deal with this, you know, like draw this mesh and give it this texture. And every mesh that it draws is a draw call, and then every texture it has to apply to that mesh is another draw call. So you can pretty much get 2 draw calls per separate item that you're trying to render in your game. So if you have lots of unique meshes in your scene, or someone's modeled something very inefficiently, so in a game that we were working on, the guy modeled a dinosaur and a King Kong, which were having a fight. I think there's a screenshot later on, but each individual toe of the King Kong that he'd made was a different mesh, and it wasn't combined. So and they each had a different texture on as well. So that was like 8 draw calls just for his toes. And then each eye was separate. So it was a really inefficient way of modeling. So when you're trying to put things on iOS devices, you want to tell the renderer to do as little as possible. So you need to combine as much as possible, really. And that includes meshes and textures. And memory usage is pretty much the amount of memory you're using from sound and textures and scripts. Pretty much sound and textures is the main thing, though. Just an overview of kind of platform limitations. The main thing is if you look at the iPad and the iPad 3, and the time difference between those two coming out was like a few years, but the actual memory of the devices and the draw calls that you can push on them are just insanely different. There was real discussions when people were originally developing for the iPad of like, what can we get away with, what do we need to do, and there was set guidelines of what you could and couldn't do. And now it's opened up so much that it's kind of a case of, well, it depends on what game you're making and what you want to do. But with the iPad 3, there's other things like resolution can affect the performance of your game. But yeah, just the advancements are so incredible. And when we look at the Unity 4 stuff, well, there's new features coming in there which are only possible because of new hardware. And a little thing like targets. So 16.6 milliseconds, the time it takes to render a frame. That includes all the script execution and the rendering and everything like that. That's the speed your game needs to run at behind the scenes for you to achieve 60 frames a second. But for 30 frames, it's obviously 33.3. But if you think about targeting these, the more you add into your game, there's less of a ceiling that you can hit. So there's just a little example of where that's shown in the basic Unity profiler. But there's performance impacts on that. So if you add 5 milliseconds per frame, it impacts your game greater than if you're trying to target 60 frames a second than it does for 30 frames a second. But my main bit of advice is just do tests. Outline what it is you're trying to make with your game. Whether you're an indie on your own or whether you're a studio, it's just test on the device. If you're trying to deploy to Android as well, pick a few target devices that you want your game to run on, which are maybe comparable to iOS devices that you're looking at targeting as well. So if you're looking at just iPad 2 and above, or iPad 4S, iPhone 4S, or if you're looking at 3GS, you need to look at similar devices on the Android, but also look at different screen resolutions and DPIs as well. So do tests and work out what the differences are. It's such a minefield. That's the best bit of advice I can give on that point of view, really. So we come to the first thing, which is controls, and especially on like touch screens. So if you want to develop a game for an iPhone or an Android device, then you're going to need to be able to touch the screen. So people always say, well, how do I do touches in a Unity game? Because what you want to do is you want to make your game as much as possible inside of the editor, really, and test it, to limit those times that you spend building it and then deploying it and then testing it and something going wrong. You want to do as much as you can, and that's where the testing originally comes into play. It's because you know what will work and what won't work. So as long as you start building your game and making sure that you know whether it's running, it's about building it inside of the editor to make sure you're efficiently developing your game. So for basic touches, if you just want to use a single touch, just to touch a button or something like that, well, Unity replicates the mouse inputs as touch inputs. So a left mouse click in the Unity editor, which you've scripted, is exactly the same as one touch input on the device, and you don't need to do anything else. When it comes to more specific touches and targeting different, like if you're doing multi-touch, well, that's slightly different. But if we look at, for something, this is my awesome game that I made. And let me just grab this. Oh. My soldier. So I've got a basic player control script here. And I developed this for the editor, to test in the editor. And I've got this section here in update. And it's just looking for a touch of the mouse button. And just saying, if input.getMouseButton up, so every time that mouse button gets released, do something. You can put this and then deploy it to iPad. And it'll say, well, if we're looking for a mouse touch, well, why don't we just look for a touch on the screen? And it'll look for that touch on that screen. And what we're doing when we do this is doing a check tapped location, which is this function up here. And what we're doing is we're casting a ray cast, or we're doing a ray cast. So from the camera that we specify, we're shooting a line straight from that camera where we touch on the screen into the world. And then we just look at what we're hitting. So in Unity, you can give tags to objects. So if it's got a collider on it, you can say, well, this is part of the level geometry. So we're just looking at level geometry here, and we're just looking at the point that we're hitting. And that's how you replicate a touch and just looking at something. It's just by using the mouse inputs and the mouse APIs. But when it does come to looking at multi-touches, well, you hook into the Unity Touch API, which there's extensive documentation online. And that's just an example, really, of the differences. So the one in the top left is just me doing a mouse input. But the one on the right, then, is for touch targets. So you can see that we're looking at touch counts. So every time you touch something, Unity picks up that you're touching it, and it'll increase the touch count. So you can check things like how many fingers are on the screen. If it's just one, then you can just fire a raycast from that point. But if it's two, you can say, if I've got 2 touches, track these 2 touches and the actual positions that they're in over time, and see where they move. So you can look at swipes and kind of directions and things like that. But alternatively, there's lots of stuff on the asset store. So again, coming back to the asset store, should be online. Yeah, I'm online. There's things that you can download which will just do all that stuff for you. So if you're not the greatest coder and you think it might take you weeks and weeks to get touch inputs, well, there's a few things on the asset store, so let's just have a look. I think there's one called finger gestures. This is going to run. My delete doesn't work, that's true. Let's see if we can find it in here. So it's usually on the top. There we go, finger gestures. So it's $27, which could save you like 2 weeks of work. And that includes all the swipes and drags and touches and releases and everything that you'd ever need. So what we're finding is that studios who are developing content for clients, for like client work and for advertisements and things like that, they have a very limited time frame. So they can spend 26 euros and it can save them 2 weeks of work, and they can get their developers using something else. So things like finger gestures are really, really important. But if you did want to roll your own input gestures, then it's about looking at the scripting APIs, and pretty much everything that you can do inside of Unity has been documented. So you can look in here and we can search for touch, and we'll get all the touch. So we can look at finger IDs and positions, and there'll be examples there of how to use those. And okay. So that's just looking at if you want to recognize any key on a keyboard, it tells you how to do that. Also things like raycast. So the raycast script that I had on that is pretty much stolen from here. It's just a case of copying and pasting it. If you want to use JavaScript, you can, but there's also C# and Boo examples of these as well. So anything that you want to do which everyone else could possibly do, the basics of game development, it's all been documented here. So you can search for it and you can grab hold of it and you can learn how Unity uses that. The advice on kind of you doing your own touches is to take this example, which you can get from those APIs, and work out how one touch works, and just get that running. And then using kind of if statements or whatever, put a different parameter in there. So if it's 2 touches, maybe look at targeting and looking at those in the direction that those are moving in over time. So platform-dependent code compilation. So if you do go and decide and have separate mouse inputs and touch inputs, if you're doing multi-touch stuff, then the mouse inputs aren't going to be needed when you're actually putting it onto the device itself. So it's wasted code, and it's just no point having it there. But you can do platform-dependent compilation of your code. So using these basic if statements, pretty much, you can have all your mouse stuff. So when you deploy it on, or you're playing it in the editor, it'll run and it'll compile. But then when you want to put it onto the device, you can encapsulate it inside this if statement, and it will never compile when you're pushing to that specific device. I don't have an example there, but it's a very simple thing to put in. So if you are looking at cross-platform development on multiple platforms and looking at web players and things like that, and there's a big chunk of code which you don't need, then you encapsulate it inside an if statement, and it'll never get compiled, so saving on your file sizes. So this is where it kind of really gets important, I think, is memory management. And this is, well, if people say that usually on like iOS, it's down to memory management. Or the other classic one is it crashes after a while. Well, it's memory management. And that's the one that normally happens, is people load up their game, they go, brilliant, it works. And then they start putting in like GUIs, and they bring in GUIs, and the memory allocation goes up, and they're not getting rid of certain like menus at specific points, and they're just running out of memory, and the app will crash. So this is the most common thing which people have issues with, and there's a few areas which people always come back to me and say, like, oh, we're doing it this certain way, and I go, oh, that's probably the issue. So we'll have a look at that. So the first thing is to optimize texture settings. And I'm just going to load up a different project very quickly here. There we go. And this is just a kind of example of a game being put together. So there's lots of stuff going on, but it's kind of replicating how a project would look if you're in the middle of developing it. Let's wait for this to load. How many of you here have developed an iOS game and released it with Unity? Is anyone? Okay, so look at this. So you have a bunch of textures that you've made. So you maybe made them in Photoshop. So you can make textures in Photoshop, and you can save them as a PSD, and you can put them in Unity. And they'll just work as PSDs. The conversion behind the scenes is done automatically when you go to compile your game, but you can use PSDs natively. So if you want to change any of your textures, then you can just pretty much grab it, and these are all PSDs, and you can open it and open up in Photoshop. And what that means is an artist can just save all their files and upload it to your server or wherever you're holding all your art, and you'll get it inside of your game. But if they need to change anything, they can open it on their end, change the PSD, just click save, not have to re-export anything, and it will update in your game as well. So let's look at something like this texture here. You can see that? Yep. Okay. So there's a few settings here. And if you notice down in the bottom, we've got the resolution of the texture, which isn't square anyway, but never mind that. We've got how it's the actual format of it as well. And we've got the size, so it's taking up 0.6 megabytes, which is pretty big for a texture, particularly for iOS. So we can look at reducing that, and we want to do it just for iOS, because if you want to put this game on the web, you don't want to get rubbish kind of iOS kind of texture sizes when you're deploying it to like a PC. Certainly those guys in the main room wouldn't be wasting those massive Alienware PCs with really bad textures. So you can look at clicking this little setting here, and this is just for iPhone. So you can override it for iPhone. You can say, well, if we're putting it on the iPhone, reduce it down to 256 and make it compressed. And you can change the compression quality and then apply it. And you can see this has changed down to 254 kilobytes now. If we want to go up to default, then we can change it up to 1024 in true color and have no actual compression on it. But that's a very, very quick way of saving lots of texture memory. So if this was just in one texture and we've saved, I can't even work out the percentage, because I'm not very good at counting. But that's one thing that people don't necessarily realize that they should be doing, and it's a very simple thing that you can do. But when it comes to having lots of GUIs and lots of menus and things like that, you can rack up your texture memory very, very quickly. And if you don't manage those GUIs properly, you could be using all of that memory from the very start of your game. And there's very simple ways that you can make sure that you're not using memory where you don't need it to be used. Because there's a very common way that people put together their menus and they don't realize it's not a good way to do it. We'll come to that in a second. There we go. It's actually what this is. So the next thing, once you do all your textures, is to manage your GUI and your prefabs. So if you're making all your menus and stuff in Unity and you want to do it yourself, and the way that I normally do it, I like to do very basic kind of GUI menus, is I have this game object here, and this is pretty much all of my GUI, and it's all exposed, and you can see it, which is fine. And I have a dedicated camera. So what this camera does is it only renders things in a specific layer. So I can call something, for example, like this game modes object here. You can see it's being rendered in my game. That's because it's got a specific layer, which is the GUI layer. If I was to change this to default, you can see it disappears in my actual game. So we can have a camera to just render our GUI objects, and we situate it away from our game, and it'll just be rendered there. And our main camera that we do for our actual game content never renders that layer, so you can never see one from the other. And it just sits on top of our game. So when people are putting together their menus, some people just have it existing in the game like this and just have it off to the side. So that when we go and start playing our game and we hit game modes, you can see it slides in. A number of towers, and then we go, and then we've got the extra ones at the top. And that's some way that people will use it. It'll just exist in their game scene. But it's using memory because it's there, it's living in your game. So it's not a very efficient way of doing it. So the next thing that people do is they say, well, when we don't use it, we'll just turn it off. So it's not on. And then when it comes to that part of the game, they just replicate this checkbox, and then they turn it on. So people don't tend to realize that things which are off in your game, for example, the pause menu here, it's there, it's in my hierarchy, it's in my game, but it's not actually visible. It's still using the memory that it would be using if it was on. So that's another way. If you do have lots of GUIs, make sure they just don't live in your game when you never ever need them. Just never put them in there. So people try and get around that sometimes, and they'll make a prefab of it. So you can create stuff in Unity, and you can kind of save it for a later date. So I can look at assets here, and I can create a new prefab just down here. I'll just call it menu. Yeah. And I can grab in, I'll take my side banner GUI and I'll drag that in there. So I've saved a reference to this. So if you see, if I turn this off, but drag this back in, here it is, it's over here for some reason. I've got another reference for that, and I can create multiple ones and reuse them. So this is great if you've got kind of multiple uses for things, and people use it for spawning new enemies, but you can also use it for GUI. And that's fine, it's good to have it as a prefab, and it's good to use it in that way. But the next thing that people do is they take a reference to that prefab so they can create it at runtime. So let's create a basic, I'm going to create a basic JavaScript file and just call it test. My horrendous naming system. There we go. So we've got this. So what you can do in Unity, you can create a variable, and I'm going to call it test GUI. For anyone who's a C# guy in Unity and you're mocking me for using JavaScript, well, never mind. But you can reference a game object, and you can say, okay, test GUI, and it's going to be a game object. And if I apply this to something like I'll create a new game object, which is creating something in your scene, and add the file to it, you can see I've got my script, and I've got a reference to this test game object. So what some people will do is they'll grab their prefabs. I can grab any one of them, say score, and I can put it in there. So it's not in our game. Like it's in our project, but it's not in our game. But I've got a reference to it here. So through code, I can choose to instantiate that any time. So if it's a pause menu, for example, I can say load the pause menu. But as long as it's got this reference inside of Unity, it's allocating the memory that prefab will use. So it's not in our game, it's not turned off or anything, it's just existing in our project. But because we have that reference, any memory they would ever use is already pre-allocated. So you can do your entire menu this way and load up a blank scene, and you'll still use the memory that you'd use if you had your entire game running. So that's a really important thing to remember. So the way that you should be doing it is to load it from resources. So you can create a resources folder. And inside here, I have something called stats menu. And this is one I made earlier, to use a Blue Peter phrase, if you're ever familiar with Blue Peter. And somewhere inside this massive script, I should have somewhere. Okay, here. So if we look at this line, I have create a new game object, and instantiate resources.load, and then stats menu. So I'm using the name of the actual prefab itself, and I'm loading it into the scene. So it's grabbing it from my resources folder, and there's no reference to it. It's just taking it, so it's a little bit slower. But what it means is that memory isn't allocated until it's actually in our game. So when you come to stop using this stats menu, you can just destroy it, and you can unload all the memory usage for that, and then you've freed up all the memory usage. It doesn't live in your game when you don't need it. So if you're doing very complex games or lots of menus, even a very, very simple 2D game, or especially a 2D game which uses lots of textures, you can very, very quickly use your memory usage up. So you can see an example here. That stats menu doesn't exist in my game, but when I click it, it loads it up. And I have it there in my game, and I've got finger gestures working on a mouse, so I can replicate how it would work on the device. And then if I want to get rid of my menu, I've got a nice little slide down, and there we go, it comes back up. So when I use it, it's using the memory. When I get rid of it, it gets rid of the memory. So if you look at putting your actual menus and stuff together in a way that you can just use them and then get rid of them, that's the best way to do it. Never have menus just living in your scene for no reason. Never do what I'm doing here and just have them living on the sides. It's good for testing, but never kind of get lazy, really. Cool. So the next side of things is optimizing the rendering and reducing draw calls. And this is what I was talking about very briefly earlier on, is just to combine as many things as possible. And the first way you can do that is on textures. So if you have like 4 or 5 different textures, well, power of 2 would be best, so then you can offset it in the right way. Then put them into one texture. Depending on the quality that you want to get out of the texture, you might need to make it higher resolution, but overall you should get a lower texture memory usage. And I've done that on those ones that we were looking at here. So if you look at this texture, it's just 4 colors. It's a very, very small texture. And I can reduce that down to whatever I want, especially if you're using block colors. You can use very, very, very low resolutions, and it won't ever look the same because you're just rendering that. So it's 3 kilobytes, rather than if we had it at the max resolution, it's 12 kilobytes. But when you're doing that with a lot of textures, especially these ones with the rounded edges and need transparency, you need to reduce this down as much as possible. So instead of having kind of 4 separate textures there, which might be 254 kilobytes each, we're only using 254 kilobytes for one texture. And then we can just use one material and offset the actual values to render in a specific way. Yep. So on this one, I've got an offset on the tiling. So it's made it half the size and offsetted it. So we're only displaying one part of this texture at any one time, although there's a bit of bleeding on the side of that one. So if we look at this scene, this is the game I was alluding to that we put onto the web and then tried to push onto an iOS device. If you look at this, there's lots of meshes going on there, but why is there a transition on that? Those are the only textures that we use, so it's 2 texture sheets. And we just offset the values, so we're saving a hell of a lot in terms of texture memory there. We were lucky because we only had pretty much block colors with very little detail, but it does save on whatever you're doing. Level of detail as well, so if you're using lots of meshes, you can use the level of detail system inside of Unity to be able to change the way that the renderer needs to render specific objects. So if you have these pillars, for example, and you're really far away from them, you don't need to render the really small details because you don't actually see them. So you can look at using Unity's LOD system to be able to automatically do that for you. And I'll show you a very, very quick example here. Oops. Should be in this one. Let's wait for this to load. Has anyone used the LOD system in Unity? No? It was part of 3.5, so we introduced a load of new features as a point release. So anyone who owned 3 got these as a free upgrade. Oh, there we go. So inside of here, I have a stone fence. There we go. And I have a bunch of meshes. So you can see, if I expand this, I have this first mesh, which if you can see it on the bottom right-hand corner, it's 806 triangles. I have the second one, which is 196 triangles, and I have the third one, which is 36 triangles. So obviously this one is very low resolution, and it doesn't, it's not the most detailed of meshes, but for what we want to be doing, it doesn't need to be. So let's jump somewhere inside of this game. We can call it a game, there we go. And I'm going to create an empty game object, which is just nothing until I tell it to do something. I'll call it LOD. And I'll add a component, and a component is what makes something be something. It does what it should be doing, what you want it to do. And under rendering, we have a LOD group. We just add that on there. And you can see on our game object, we have a LOD group component, and we have a bunch of inputs here that we can put into it. So for LOD 0, this is going to be our most detailed mesh, the thing that we want users to see when they're really close up to it. And this is going to be this first one here. So if I want to use that, I just drag and drop it in. Tell it to reparent, it puts it into our scene. For the second one, I'll drag this into LOD 1. And for the third one, I'll drag this into LOD 2. And then we have cold. So if it's beyond a certain distance, it never renders it anyway. So if you look in our game, let's change this to perspective. We have this object, which is in LOD 1, LOD 2, and eventually it gets cold. So you're reducing the impact to the renderer by sending it less detailed meshes. So there's one thing telling it to do less, and then the other thing is telling it to do less complicated things. So it's kind of like telling someone to do like star jumps, and they'll get pretty tired really quickly. But if you tell them to just jump, then they'll find it a bit easier. I don't know. Doesn't seem like a very good analogy, but there we go. Next thing is overdraw. So this is where you're rendering things which you don't need to be rendering. So by default, rendering works kind of from back to front. So the things that are really far away, so those guys who are at the other end of this kind of corridor, I'd be rendering them first with my eyes if I was a machine. I'm not. And then I'll be rendering you guys in the front afterwards. So if there's anything obstructing that, I've still rendered those guys before I even need to. But you can use things like occlusion culling to be able to automatically judge what you can and can't see, and then only render what you should be able to see at that point. So if we look at this example, the bottom is how the player will see this level, and the top is how the renderer will actually be rendering it. So you can see lots of stuff in the background which is being rendered, and the brighter areas are things which are rendering behind other things, and the brighter they are, the more things they're rendering behind. And this isn't the most efficient way of doing things, because obviously it's a lot of waste. But if we're using something like occlusion culling inside of Unity, we can reduce it down to this. So now we're only rendering the things that we should really be able to see, and if we really refine those the parameters that we have inside of the occlusion culling, we'll be able to refine that even more. But for now, this is a huge improvement on a scene which isn't optimized in any way at all. Each wall is an individual wall itself. So you can see we've reduced our main thread down by 2, but we've reduced our draw calls down from 162 to 31, and there's no visual impact to the player itself. So occlusion culling exists inside of Unity under Window and occlusion culling. And it pretty much just creates a grid inside of your scene. You can see it just about here, hopefully. Yeah. And you'll get basically a virtual camera which will move around your scene and look around each individual grid point, and it'll say, what can I see from this point? Is there anything which is behind another object? And then when you as the player move around and it uses the game camera, it'll say, well, I'm in this cell. What are the objects which I should be rendering, taken from that virtual camera which moves around? So it's a very, very good way of optimizing, specifically on iOS as well. Bake lighting and use light probes. So where you can, don't use any lighting and bake the lighting into your scene. I've got an example of this here. So any lighting that you try and do on an iOS device, because it's got a very small GPU, is something which isn't advisable. So we have this little example scene here of this guy running around. And there's shadows and there's light which is bouncing onto the ground to make it kind of reflect the cubes. And if I move this guy over here, you should hopefully be able to see that parts of the green off the cube are bouncing onto the character itself. So you really get a feel that the guy is inside of the environment. If I walk over to the shadows of this red cube, he gets slightly darker, so he's using the shading and the shadows and that being cast from this cube. If I move back out into the light again, you can see he gets lighter. So he's reacting to the light that's in the environment, but the important thing is here that there's no lights in this scene. We have a directional light here, but I can turn it off, and there's actually no difference in our scene. And that's because the lighting itself has been mapped. So we have a couple of light maps here. So it's split up our scene, and it's looked at specific parts of it, and it's baked the actual kind of shading details onto that. And we're also using light probes as well. So if we look at our light probe group, and these are just little probes that you place around your environment where the lighting differs, and the more probes that you put in your environment, the better difference in the shading that you'll get. So what it does is it takes the 3 closest probes to the player and interpolates the lighting detail held in each one, and then applies that to the shading and the material of the player itself. So for example, with this light probe, it'll take these 3 maybe this one over here, but you can choose if you wanted to to add an extra probe just on the outside of this shadow. So it'll take these three. So there'll be a difference between where my cursor is here and where my cursor is here. Whereas before, if I just remove this, it would only be as I really enter this, so there wouldn't be that kind of real quality there. So this is a really, really good way of making your levels look really, really good. I mean, you get extra detail added when you do light mapping in terms of like ambient occlusion and light bouncing and things like that, so they can really add to your games, and you should be looking at using them anyway. But anywhere that you have objects which never move around and you want to cast shadows, bake it all in. You can still then look at doing some real-time lighting on, well, you can use this on desktop and PC, and then look at doing real-time lighting on the characters, for example. But when it comes to mobile, you'll be looking at baking pretty much everything. Cool. And use mobile shaders is the other one. And this is a kind of a real quick tip. So a material is basically a shader, so some code which tells it how to render, and then an actual texture itself. So this one's just got a diffuse color, and it's just diffuse here. But if you select this drop-down, you get a bunch of shaders which do different things, and held under here is mobile. And if we look at mobile diffuse, it doesn't use that diffuse color, this main color here. So if you've got a normal texture, which is just white, and you have a texture which is added onto it, don't have any on this, you won't need that color. There's no point adding the extra color to it. So you can choose to use mobile diffuse, and it just uses the texture, and it doesn't use any additional colors. So doing that throughout your scene as well can really improve performance dramatically. Especially if you accidentally choose, kind of specular shaders when you don't need them, and you have a whole bunch of them, and you're instantiating enemies, and they've got the wrong shader on, you have like 20 on screen, your performance is going to pretty much reduce dramatically from that point, just because you've got the wrong selection. Reduce transparent objects. That's a huge thing. So any transparencies you have, you need to reduce that as much as possible. Anything that's transparent and has a transparent background, try and combine those as much as possible. Only use one shader or one material. Some basic script optimizations. So you can't use dynamic typing, which is to say that you just tell Unity this variable is a 5. It needs to know whether it's an integer or a float variable. If you're using JavaScript, like I do a lot of the time, you can get away with that, but if you use C#, you can't dynamically type, so it's not a problem. So that's one thing which I got caught out with some of our scripts, is that some parts of it were dynamically typed. So you just need to explicitly state that it's an integer, or it's a float, or it's a game object. You can't just give it a name and say UR5, because when it comes to compiling to iOS, it gets compiled into an Xcode project, and that doesn't handle dynamic typing. You can also do it as well on get components. So instead of getting a component by the name of the component is pretty much going to be the type of the component. So it doesn't need to do a string lookup. It just needs to get the actual type itself. There we go. And also caching component lookup. So anytime that you go to a game object and get a specific script from it, store it somewhere, and then you just have a direct reference to it. So you can do it here. You can do it at the very start. So you can just say, these are all the scripts I'm ever going to use. There's no point getting them when the game's running. I might as well just drag them into the variables inside of the inspector, like what we did with that prefab. So we can always reference them directly, and it saves looking them up. This is for moving objects. So transform, for those of you who do coding inside of Unity, people just put transform and get a scale or a position and then change it. But behind the scenes, Unity's always doing a component lookup of that. Like just accessing transform directly is pretty much a shortcut to doing game object or get component transform. What you should look at doing is storing that transform from the very start. And then you access the transform directly. And that can save, because people use transform lookups really, really often, especially in updates and things like that. The next thing is to avoid using updates. I used to teach loads of students, and they used to say, well, I want to make something happen every 5 seconds, so I'm going to write a timer. And then they'd do this, and they'd have a variable which increases over time, and then it gets to like 5, and then they'll reset the variable and run a function and do something else. And they've got this script running just every frame, where you can just have it as an invoke repeating, and it'll just run a function every 5 seconds. And Unity just handles that. So it saves running everything in update, because update runs every frame, basically. So the faster that something's running, the more it's got to do something. So there's kind of a summary there in terms of the coding stuff. It's very brief, I know. General tips is do regular builds then. So like I was saying, be able to test your games, especially controls, inside of the editor. but always do regular builds, because you might just get into a big, if you've played game dev story, they go on like code burns, and they do loads of stuff, and you get loads of points, it's great. But you might be on one of those days and you put loads of stuff into your game and then you build it, and you put like 4 or 5 new features in, and your game won't run. And you don't necessarily know which one of those features broke your game. So it's best anytime you add a significant feature or a new part to your game to do a build and see if that particular thing works. Profile, so try and work out how your game is running, and there's a few ways that you can do this so that you know where things are going wrong. And the more you do this, the better understanding that you have anyway. So you can use the Unity profiler. So when you run your game, this is for Pro only, you can see how it's running in the CPU and GPU usage. If you're running it on the device, if you create a developer build, and you're running your device on the same Wi-Fi network that Unity's running, you can access the profiler remotely. So when you're running the game on your iPhone, it'll show in the profiler on your PC. Inside of Xcode, you can do profiling as well, and this is kind of separate because it tells you how the device itself is dealing with your particular game rather than how your game is dealing with the device, which is 2 slightly separate things. And you can do this through Activity Monitor as a basic way, and this just gives you an overview of memory usage and things like that and CPU usage. Or you can do it as an internal profiling, which is enabled very, very easily, but it's kind of hidden. And this will give you kind of draw call timings and how long physics is taking to render, how much texture usage is being used, and really tell you how your game is running on the device. And this will differ from iPhone 3GS to an iPhone 4, so you can really see whether you're CPU or GPU bound, meaning that whether you're having issues rendering things or just running your game. And also get someone else to test. So if you're developing for iOS, TestFlight, which is testflightapp.com, it's a free service, and you can create your builds through Xcode, and you can upload them online, and you can send links to other players. You don't need any of the device details. You just send them a link to register with TestFlight. It gets the UDIDs and everything registered to your account, and whenever you upload a new build to them, they'll get a little email saying there's a new build, and they can download it directly and have it on their iPhone, just like any other app. So that's a really, really good way of testing. There are Android equivalents for that as well. So a quick thing on Unity 4 then, before we finish. I'm going to go watch on. There's a few, for those of you who aren't aware, Unity 4 is launching sometime soon. And we're in kind of private beta tests at the moment with it, and it's going to a public beta test soon, so hopefully you should be able to get a hold of that. But there's significant improvements, and we'll go over these very, very quickly. But things like iterative light maps. So as I was saying about the light maps, so if you bake all the lighting data into your scene and you decide to move like a trash can further up the road because you think it feels better up there, you'll have to rebake the entire scene again, which takes a very long time. So iterative light maps mean that you can do little bits of pieces of your light maps. So if you do move those little objects, you can then only bake that part of the light map. You do have to have quite an iterative kind of level setup, so you can move things around quite freely. You don't want kind of blocks of level geometry, but it can really, really help. So on the AAA side of things, DirectX 11, Shader Model 5, normal maps and light maps make normal maps a lot more detailed. We've got new text rendering as well. So Linux export is coming, so you can push your games to Linux. This is going to be free for all users. So as I was saying, you can download Unity for free, and you can push to PC and Mac and also the web browser. Linux will be added to this as well. So if you're making games and you want to put it on Humble Bundle, you can totally do this without even spending a penny. Flash export is becoming a final release, so there's kind of basic and pro add-ons, as I mentioned earlier on, which allows you to export to an SWF file. So people who work at companies who might do a lot of work for hire that want to make Unity games, clients are kind of like, well, we'd rather bring on Flash because there's over 1 billion people who have Flash installed, and there's a less kind of boundaries to entry there. Oh, I'll come to that in a second. So new mobile features, dynamic shadows. So this was something which was never possible, but now you can have dynamic shadows on your objects. So objects which move around, they can cast shadows. So previously this wasn't possible because Unity didn't support it, and also because hardware just couldn't cope with it. Refined profiling on Android devices, specifically Tegra chipsets. So it's similar to the profiling that you get when you run your game in the editor. You can now have that on the device. Render resolutions, this is a huge one. So anyone who's developed for iOS and have maybe put something onto the iPad 3 and find their game doesn't run quite so well because it's running at double the resolution, you can now set render resolutions. So you can run it at half resolution on an iPad 3 and full native resolution on an iPad 2, but then it will automatically upscale on the iPad 3, so it'll all look really, really nice, but it's only running at half the resolution. So the game will run a lot easier. Android development, you can now generate an Eclipse project, so you can choose then to do whatever you wish and put in Android-specific code into your games before you put it on your device, whereas previously you pretty much just had to push it to the device itself. Dynamic fonts and OS fonts. So if you use lots of fonts inside of Unity, it creates a font sheet, which is basically a giant texture with all the font kind of written out. And so if you had a font and you just wanted to use like the A or something, or the numbers from that, and you had a font being used, you were wasting lots of texture memory because it was using every other character that was available in that font. But now it only creates font sheets as characters are being used, so it creates them dynamically. So if you have a font and you just want to write Hello World, it will only use the characters that are used in Hello World. But then on the fly, if you choose to add an extra line to that, it'll then remake the texture sheet, and you'll have the characters that you need, but you're only using exactly what you need and not wasting anything. A HTML-like markup language allows you to add stylings to these as well, so kind of bold and adding in kind of italics and underlining and things like that. You can do that directly inside of the text that you're writing, similar to how you do with HTML with writing forum posts, and you put the little B inside of the brackets, then it works exactly the same inside of Unity now. And this is huge for Asia-specific fonts, so if you're pushing to kind of Asian markets, then they have huge character sets, and you can pretty much break your game by trying to put it on with Asian characters. So having this is hugely important, and it's something which we've had massive requests for. And Mechanim is the flagship feature that we're putting in. So it's a full character animation system natively inside of Unity, which allows you to have rigged characters that someone has made and have animation data which someone else has made for completely separate characters. And you can drag and drop all that animation data on a completely separate character, and handles the retargeting. So a run cycle which someone has made for like a 6'5" basketball player can be applied to like a 4'5" goblin. And little things like, because the goblin's got shorter legs, the run speed on this run cycle will be slower, so it'll be moving around at a slower pace. You can then go through and use things like blend trees and state machines, which you can then visualize and control how the blending of these specific animations are used. So you might have that run cycle from the basketball player, but then you might have like a sword swipe for some warrior from a fantasy game. And you want to blend these two together, so you can use blend trees, and you can take in the inputs, and you can say, well, look for when enter's being pressed. And when enter's being pressed, blend these two animations together, and it handles all the blending automatically. So it was created by the guys who were behind Motion Builder and the FBX file format. These are guys who've been leading kind of character animation for the last 10 years. And now they're part of Unity, and putting this natively into the engine is something huge, and no other engine really has, and it's great for AAA devs. They can save a hell of a lot of time, but it's great for indie devs because now they don't even have to do anything. It'll be part of the asset store as well, so you can get mocap data which other people have created, put it into your games, and not have to create your own animation. So for rapid prototyping, it's brilliant. For actual for game development as well, and if you want to use that and release it, then it's very, very important. So that's pretty much it for my talk, and I'll kind of leave it with a video of Mechanim. That's pretty much it, so thank you very much.